Hey guys, welcome back to Maximum Automation. Today, as part of our Git tutorial series, we're going to discuss Git branching. What is Git branching and why do we create different branches? So let's start with today's session. Let's first discuss what Git branching is. Branching is a feature provided by version control systems like Git. A branch is basically an independent line of development. When we commit our code to the repository, then Git stores these commits as a snapshot. And branches are basically the pointers of these snapshots. When we create our repository and perform the first commit, then a default branch gets created, which is called as master or main branch. And the master branch is basically the main branch where we can say that the source code is production ready. What do we mean by production ready? It means if you want to create a build of your product, then you can always build it from the main branch. Or in case of automation, if you want to run your test suite on a production environment, then you can run the automation code from the master branch. If you see this diagram, then these nodes in master branch represents the different commits to the branch. Or you can say these are the pointers to different commits. So the first commit stores the pointers and metadata to the root project. As it is the first commit pointer, so it does not have any parent information. And when we update the code and commit again, then this next commit stores a pointer to the immediate previous commit and contains the previous commit information in parent. So each time we commit, the pointers to the branch moves automatically. With the help of these commit history or pointers, we can recreate the snapshot whenever needed. For example, if I want the copy of code from a specific commit, or I want to get the copy of the code of a specific date, then with the help of these pointers, we can get the snapshot of the code. So whenever you need to make some changes to the code, then you need to take the clone of the repository by using the git clone command. And once you are done with your changes, then you can commit and push your changes back to the repository. Once you push the code to the branch, Git creates a new snapshot. So branch basically is the pointer of each commit, which points to the snapshot of the source code. Also, in Git, we can have multiple branches, like we have a default branch as master, and we can create other branches as well. So let's first discuss why we need other branches. As we already discussed that the main or master branch is the branch where we can say that the source code is production ready, or the code in master branch is deployable. It means that in the master branch we have stable code, which we can utilize for production builds. We know that multiple developers works on a project, and they need to commit their changes to somewhere, which might not be completed. Let's say that if we have only a master branch, and each developer is committing their changes to the same branch. If you push something to master that is not tested or breaks the build, then it creates a big problem because now we cannot use the code to deploy it on production. Or if deployed, then the bugs will be reported. Let's see here that developer A takes the clone of the project into his machine and starts updating his changes. And then at the same time, developer B also takes the changes from the head of the branch. Now let's say developer A pushed his changes back to the branch which contains the bugs in the code. And then after developer A committed his changes, there is another developer C who took the clone of the repository from the head of the branch. Now the issues in the code is transferred to this developer as well without knowing the issues. And then everyone is gonna push to the branch, which will create multiple commits with the issues in the code. And there might be a huge number of commits until someone identifies the issues in the code. And then it will create a big problem to revert the changes or to introduce the fix so that we can use the code for the deployment. So to avoid these issues and to make the master branch always stable and safe to deploy, we need to create another branch from the master where developers can actively push their changes. Let's say that we create a develop branch from the master. Then developers won't commit their changes directly to the master branch. They are going to commit all their changes to the develop branch. Once the develop branch is tested and made sure that nothing breaks, then the changes from the develop branch can be merged to the master branch. In this way, the master will always contain the stable code. So whenever the developer wants to do some changes, then they can take the clone from the develop branch. And once done with their changes, they can commit their changes back to the develop branch. In case a developer introduces a bug in the code, then the master branch won't be impacted. And once all the developers are done with their changes, then the code needs to be tested in the develop branch. Once done, then the team can merge the code from develop to master branch, which is going to make the master a more stable branch because the code is already tested. So what happens when we create a new branch? Let's see in this diagram. When a new branch is created, then it means a new pointer is created to move around the commits. Let's say we have created a develop branch. From the master, then master and develop both will point to the same commit. And now the team is working on developing a branch and commits their changes to the same. So each time we commit, the pointer to the branch moves automatically. And when we think that the code in the develop branch is tested and ready to be merged into the master, then we merge the code to the master, which means that the pointer of the master branch also points to the latest commit. So this is how the master and develop branch works and considered as the main branches of the repository. Then we can have another branch called as feature branch or individual branch. Now what are feature branches? If we look into this diagram, and when a developer took a clone of the branch to their machine, so it is not necessary that they are going to commit their changes in one go. They might need to work on bigger functionality, which requires some time to get completed. And they don't want to commit their incomplete work to develop branch, because this is the branch which is used by the other developers. So in this case, developers create their own local branches called as feature branches and keep committing to their changes to their respective feature branches. And once they are done with their changes, then they merge their feature branches to the develop branch. So these feature branches can also be pushed to the repository so that in case of your system crash, you won't lose your changes because you have your changes committed to your feature branch. When feature branches are merged to the develop, then developers can delete their feature branches. And for developing a new feature further, they can again create a new feature branch from the develop branch. So these were the basic branches which we should have to maintain our source code. Apart from these, we can create other branches as well as per the requirement. Like a team can create a release branch to maintain the code specific to any release, or they can create another branch only for fixing the defect. So it totally depends on the requirement and the nature of the project. In my next video, we'll see how to create, develop an individual branches or feature branches and how to push your code to your respective branches. I hope you guys have enjoyed this session. In case of any doubt or query, please put the comments in the comment box. Also, please do not forget to subscribe to the channel. Thank you.